All right, video 4 is all about absolute value equations and inequalities. Now, absolute value, you should have seen it at some point. The absolute value of -8 is, it is 8. And with that, the absolute value of 8, let me put it here, absolute value of 8 is also 8. Here's the thing. Absolute value is always going to be positive. The definition of absolute value is the distance on the number line away from 0. So, -8 is 8 units away. 8 is 8 units away from 0. So it's always positive. That's the main thing. Now, the other big thing is how to solve. You've probably seen this before. If the absolute value of x is 3, well, what is the value of x? Well, x is going to be equal to 3, and it's also equal to -3. X is both 3 and -3. Another way to write that is you could write that x is equal to plus or minus 3. Again, when we're solving, you're trying to find all possible values that work in this scenario. So the absolute value of 3 is 3, absolute value of -3 is 3. All right, so that stuff is easy and should be review. Ooh, one quick one here though. If the absolute value of x is equal to -7, what is x? Well, since the absolute value is always positive, this one is no solution. There's no way to get a negative value from an absolute value. All right, so let's go to solving. Let's do a couple of examples here. 2x plus 5, the absolute value of that whole thing equals 10. All right, now, this first one, I'm going to do it a long way just to show you what's happening here. Instead of 2x plus 5 is, the absolute value of that is equal to 10, let's talk about the absolute value of a equals 10. Well, if the absolute value of a is 10, that means that a 2x plus 5 is 10, or we can say that -a, right? -a is 10, or we could say that 2x plus 5 equals, because that's a, and moves this negative to this side, is -10. So we have to set up two different equations here. So 2x plus 5, or excuse me, subtract the 5 from both sides, you get 2x is equal to 5. X is 5 halves. And then the other solution would be 2x equals -15. X equals -15 halves. Those are our two solutions here. Right? How could you check your answer? Plug them in. 2 halves times 5 halves is 5, plus 5 is 10. The absolute value of 10 is 10. And then here, plug this one, and you get -15 plus 5 is -10. The absolute value of 10 is -10 is 10. So, think of this as coming up with the absolute value of this is 10, and the other one is going to be -10. I don't like what I just said there. Neither. Let's do another one. How about absolute value of 20x plus 1, the absolute value of that whole mess, minus 3 equals 4. All right, so this problem's a little bit different than this one in that here the absolute value was by itself. So before we split off and everything, let's get the absolute value by itself. In other words, get rid of this -3. So now we're at the absolute value of 20x plus 1 equals 7. Absolute value of 20x plus 1 is equal to 7. Now, again, think of this as a. I'm going to come up with two different formulas here, or equations here. The reason why, or our first equation rather, is 20x plus 1 equals, well, this thing can be 7, right? Or 20x plus 1, this thing is equal to -7. and solve each one. 20x equals 6, x is 3/10. And then in this one, 20x is -8, x is negative 2/5. Reducing fraction. Oh, that's a 5. Awesome, awesome. So what's inside here can be either positive or it can be equal to -7. Where it gets tricky are inequalities. So that's our next section, our inequalities. Inequalities. And there's 2 words that I need you to know. Actually, they're pseudo words. The first one I want you to learn is less than. That's a funny word, Mr. Smith. And the other one I want you to learn is greater. Smith, those aren't even words. I'm pretty good at English, and I don't think that those are words. And you're talking all crazy and stuff. You're right. Let's do our first example here. How about the absolute value of x plus 7 is less than or equal to 3. All right, so here's what's up. Just like before, we're going to make 2 different equations, right? Now, let's think of x plus 7. That's our a, right? So we're talking about the absolute value of a. So that means that x plus 7 is less than or equal to 3. And because this is a less than symbol, we're going to put the word and. And now we're going to do this x plus 7. Now, x plus 7 has to be -3. But here's the thing. We're also going to flip this sign. Whoa, 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 Smith. Why are we flipping a sign? All right, for those of you who just need to just be told to do this, go ahead. But let me show you, for people who like to know why, let me show you why. The absolute value of a is less than or equal to 3, right? So that means that a can be 3, right? So we say that a is less than or equal to 3, right? Or in this case, the absolute value of a, that means that negative a, right, is less than or equal to 3. The absolute value of negative a is still going to be 3, right? So it doesn't change it. But when it's out here, when we take away the absolute value, we have to get rid of that negative. And how do we get rid of that negative? We divide by a -1, right? So when we do that, we get a. When we divide by a negative number, this switches the sign, greater than or equal to -3. All right, so that's why this symbol gets switched. Just like before, we're going to set up 2 different ones. It's going to be this thing and the +3, and it's going to be this thing and the -3. However, when the +1, it stays the same. When we do the opposite of the right side, we have to flip the symbol. All right, so solve each one of these, and let's graph this. So x is less than or equal to -4. X is greater than or equal to -10. Super. So let's graph this. -10, -4, and because this is an and problem, because this is and between here, this is our answer. Let's graph each one of these separately. We say that x is less than or equal to -4. That means this is a solid dot going this way, all the way across. And then here I got solid dot going this way, like that. Because this is an and problem, our final answer is this center section. There it is. All right, now I hear a couple of you, Mr. Smith, why is it the middle? Why is it and? Now you just said it was and. How am I supposed to know for sure? Let's see. If we take -5, for example, that's between here, right? -5. -5 plus 7 is 2. The absolute value of 2 is 2. Is 2 less than or equal to 3? Yes, that's why negative 5 is in this region, thus that is part of our solution. What if we're outside, like a number like 0? 0 plus 7 is 7. The absolute value of 7 is 7, less than or equal to 3. No, that's why these outside posts are not shaded, because these are not solutions. So if you forget less than, now you can still test it and figure out which one it's supposed to be, but I like the less than just so that we remember. That brings us to greater. In fact, let's do the exact same thing. X plus 7 is greater 3. We're almost doing the exact same problem except that it's greater than. Right? So we're going to set up two different ones. We're going to set up x plus 7 is greater than 3. Greater x plus 7. Remember, you got to flip it for this one. Less than negative 3. So x is greater than negative 4, or x is greater than negative 10. So our graph is going to look pretty similar here. All right, we got negative 10, negative 4. Graph each one separately. All right, we're graphing this thing here. So this is open circle going that way. X is greater than... Oh, snap. What have I done? Oh, I flipped this. I wasn't supposed to flip that. My bad. Thank you. This way. So, my bad. X is less than negative 10. That goes this way. See how it's the exact same problem, except that it's got the different symbols. So, whereas and it was the middle section, or is going to be the opposite section. And you can test it, right? Before, 0 did not work for this first one. 0 plus 7 is 7. The absolute value of 7 is 7. 7 is indeed greater than 3. Right? So that's why this is a solution. How about negative 100? Negative 100 plus 7 is negative 93. The absolute value of negative 93 is 93. 93 is greater than 3. That is true as well. So that's why this is a solution. This middle part, if you don't believe me, try it. Plug it in. It won't come out to be the right solution. All right. Tomorrow, I'm going to bring in some wonky stuff for you. Thanks for watching.